Hello students, good morning. Welcome in lecture number 4, Unit 2, paper number 506. Last lectures we studied about classification of drugs and two groups of drugs like anti-TB and anti-leprotic drugs. Now in this lecture we are studying about enthalminetic drugs. As per our syllabus, there is a number 3 is anti-diabetic drugs. But I arrange timing, so we will study anti-diabetic drug in last lecture. So we skip it here and we start from enthalminetics drugs. In these drugs, we have compound like vioform 2,2-dichlorobutane, N-hexyl resorcinol and lubisan. But vioform is not coming in this class. It is antiseptic drugs. So we also skip the vioform. And in synthesis we have only three compound 2,2-dichlorobutane, N-hexyl resorcinol and lubisan. So in this lecture, first of all, we studying about enthalminetic drugs, introduction, and then synthesis of drugs and their medicinal application. So we start with introduction. Helminthiasis is a disease caused by infestation with parasitic worms living in the eliminatory canal or in the other tissues of the host. This disease is one of the major prevalent diseases in the world, particularly in the tropical countries. The main reasons responsible for the widespread nature of this disease in the developing countries are the lack of adequate sanitary facilities and supply of pure water, coupled with poverty and illiteracy. The helminth infection can be acquired either by there is some reasons for the enthalminetic disease. Number 1, contact with infected animals. Number 2, by the ingestion of infected meat. Or number 3, by the animal or human excrete via ground or water. Or number 4, by means of certain mosquitoes, as for example, filarial worms are transmitted via blood-sucking mosquitoes. The worms enter the body in the form of either larvae or the egg form. In some cases, they produce disease immediately, whereas in other cases, they take weeks or months to produce disease. Thus, to take preventive measures against these worms, one should have exact understanding of the life cycle of helminths, that is worms. The main danger of helminthiasis is that the worms may burrow into tissues, thus causing injuries to vessels and organs. They may cause loss of blood, neutrophil deficiency, urticaria, and other allergic conditions. The main parasitic Worms found in India are roundworms, hookworms, threadworms, tapeworms, Geneva worm, and Filarial Worms. Enthalmyletics. The enthalmyletics are the drugs which are used to kill or remove the parasitic worms such as hookworms, roundworms, tapeworms, etc. Those enthalmyletics which kill the worms are called vermicidal. Please note that vermicidal. What is vermicidal? The enthalmynetics which kill the worms are called vermicidal, while those which help in expelling them by making the environment uncomfortable for living are called vermifuge. Vermifuge. So in this point there is two definition, vermicidal and vermifuge. An ideal enthalmynetic should fulfill the following characteristics. This is the characteristic of the enthalmynetic agents. Number one, it should act either specifically or inimically to all worms. Number two, it should not be toxic when it is absorbed from gut or when administered parenterally. Number three, it should not necessitate elaborate preparation or precaution in the direction of dietetic restriction of choice of purgatives. Number four, it should be cheap. Now, enthalmynetic may act by causing narcosis for paralysis of worm by either penetrating the cuticle or by the worm ingesting. It may damage the cuticle of the worm or partially lays it. The specificity of enthalmynetics reveals that they interfere with metabolism of the worms. Each worm is having its own metabolic requirement. The available enthalmynetics may be classified in two different ways. This is the classification of enthalmynetic agents. Number A, according to their chemical structure, and number B, according to their action against the specific type of helminths. We see both type of enthalmynetic agent. Number A, according to their chemical structures. In this class, they are subdivided in number 1, chlorinated hydrocarbons. Number 2, phenols and related compounds. Number 3, antimonials and arsenicals. Number 4, piperazine derivatives. Number 5, triphenyl methane and cyanide dyes. Number 6, miscellaneous compounds. And number 7, natural compounds. And number B, according to their actions against the specific type of helminths. The enthalmynetics may be classified as follows according to the worm on which they act. So we have sub classification here. Number 1, against tapeworm, mepacrine, chloroquine, dichlorophene, melphalan, pelatrine, hexyl resorcinol, niclosamide, etc. are used against tapeworm. Number 2, against hookworm. Tetrachloroethylene, oil of chenopodium, hexylresorcinol, bifinium, hydroxynaphtholate, thymol, carbon tetrachloride, thybendazole, triclophenol, and piperazine are against hookworms. Number 3, against roundworms. Piperazine citrate, bifenium, hexylresorcinol, diethyl carbamazine, centonin, oil of chenopodium, thybenzadazole, triclophenol, piperazine, stilbasium iodide, etc. against roundworms. Number 4, against threadworms. Oral treatment with crystal violet, diphenan, hexylresorcinol, phenothiazine, piperazine, viprinium, dithiazanine, thiabendazole, stilbasium iodide, oxytetracycline, etc. against threadworm. Against strong glioids, stercorils, crystal violet, dithiazine, viprinium, etc. are against strongyloids, stercoils. And last, against worm living outside the alimentary canal. A. Microfilaria, diethyl carbamazine. Number B. Bilharzia, antimony tartrate, stibofin, anthiomeline, myracil D, etc. are against worm living outside the alimentary canal. There is no satisfactory treatment for infection by other flukees. So this is the introduction, and in this class we studying and synthesize three drugs. So first is 2,2-dichlorobutane. 2,2-dichlorobutane is synthesized from methyl-ethyl ketone or butane 2-on. Here is the structure of methyl-ethyl ketone. This methyl-ethyl ketone is treated with phosphorus pentachloride PCl5. On this reaction we get 2,2-dichlorobutane. This is the short root of 2,2-dichlorobutane as enthalminetic drug. So this is synthesized from methyl-ethyl ketone and one step reaction. Now, medicinal application of 2,2-dichlorobutane. Its enthalminetic activity has been found to be equal to that of carbon tetrachloride and tetrachloroethylene. However, it has fewer side effects. This is the medicinal application and side effect of 2,2-dichlorobutane. Now, second compound in N-hexylresorcinol. It is also known as caprocol. It is the trade name of N-hexylresorcinol, caprocol. It is synthesized from resorcinol. Here, stated structure is resorcinol. Resorcinol is treated with caproic acid C5H11COOH in presence of fuse zinc chloride ZnCl2. We get 1,2,4 dihydroxyphenyl hexane 1 on. We get, I repeat the name, 1,2,4 dihydroxyphenyl hexane 1. Now, this 1,2,4 dihydroxyphenyl hexane 1 is treated with acid metal reduction in presence of zinc plus HCl or mercury plus HCl. We get N-hexyl resorcinol. Here noted that in presence of zinc or mercury in acidic media, the CO group, CO from here, is converted into CH2. So, 1,2,4 dihydroxyphenyl hexane 1 on is converted into N-hexyl resorcinol. This is the synthesis of N-hexyl resorcinol. N-hexyl resorcinol is synthesized from resorcinol. Now, medicinal application of N-hexyl resorcinol. Phenol coefficient of this compound is 147. Some compound have given phenol coefficient number and N-hexyl resorcinols, this phenol coefficient number is 147. Second point, N-hexyl resorcinol is well known urinary antiseptic and urinary antiseptic. It have some antiseptic actions also. It is commonly used for treatment of a crisis and tapeworm infections. Now, lubisan. This is the last compound of this class. Lubisan. It is synthesized from resorcinol monobutyl ether or 3-butoxyphenol. 3-butoxyphenol or resorcinol monobutyl ether. It is stated here. It is reacted with carbamyl dichloride COCl2, carbamyl dichloride. So reaction with carbamyl dichloride, we get carbamate chloride of resorcinol monobutyl ether. We noted that in the reaction there is a COCl group, COCl, this is the COCl, is substituted from this hydrogen and this COCl is from carbamyl dichloride and removal of minus HCl. After this, the carbamate chloride of resorcinol monobutyl ether is treated with ethylene diamine NHC2H5 twice. NHC2H5 twice. So this ethylene diamine is introduced in carbamate chloride derivative and removal of HCl and we get lubisan, our final product lubisan. This is the synthesis of lubisan from resorcinol monobutyl ether or 3-butoxyphenol. Now, medicinal application of lubisan. It is used as anthelminetics. Chemically, it is the diethyl carbamate of resorcinol monobutyl ether. Lubisan is also chemically known as diethyl carbamate of resorcinol monobutyl ether. Thank you.